Homework, page 317. Number 2 is 3/2. Number 4 is -6/5. Number 6 is square root of 3 over 2. Number 8 is 8 times square root of 7 over 21. Number 10, the cotangent is -2 times the square root of 2. And the secant is -3 times the square root of 2 over 4. And 12, the sine is -square root of 21 over 5. The cotangent is -2 times square root of 21 over 21. 14, excuse me, is the sine is -65 over square root of 65 over 65. The cosine is -8 times square root of 65 over 65. 16, the tangent is square root of 15. The cosecant is -4 times square root of 15 over 15. Number 18 is -0.61. 20 is 0.18. So, what of those questions do we have before we do a few examples, assign some homework, and then almost certainly get to the next lesson? I'm going to have time. 8 through 20. Well, is there one in particular that you want to start with?
8 is the only one top section for demonstration.
Okay, great. 8. If the secant of theta equals 8 and tangent of theta equals 3 times square root of 7, find the cosecant of theta. So, what should we do?
Start. I don't even remember how I. Oh, you can change the change it to.
We can do the formula tan plus 1, tan squared plus 1 equals secant squared. We have that. Can you use these as
I
like,
just draw the triangle on these, right? That's what I would do.
how do you know when you're supposed to when it'd be best to draw a triangle or do it?
Always do whatever the easiest way is. The easiest way possible. If you don't have to go complicated, don't do it. So it says the secant of theta is 8. What is secant?
Cos.
It's the reciprocal of cosine. That's true. But what is it in the triangle?
Adjacent.
Hypotenuse over adjacent.
Hypotenuse over adjacent. Now, something that, as I was thinking about this is the last one of this problem, so I'm kind of thinking this is probably this is probably going to be code to play on this particular problem. It might not actually be 8. How could the secant of theta be 8, but this side not be 8?
If the one is like 2 and the
Right.
other 16.
Yes. So it might be reduced. Okay. So that may be what happened with this problem. The tangent is 3 times the square root of 7. So what is the tangent?
Opposite over adjacent.
Opposite over adjacent. So 3 times the square root of 7.
And
Or
the
what?
adjacent is already one.
Totally works. So we're supposed to find the cosecant. Let's see. What is the cosecant?
It's the hypotenuse over opposite.
Hypotenuse over opposite. We got a problem. We don't like that answer. It's ugly. So we should unuglify it.
Multiply top and bottom by square root of 7.
Accurate. This one is going to turn into 7, right? Square root of 7 times square root of 7. And 3 times 7 is 21. So 8 times the square root of 7 over 21.
I don't know what I did the first time.
Probably just a mistake or something. Or did you try, or did you solve it a different way?
I didn't use the triangle, I did the other stuff.
And you could do that. You could do what Aiden was saying. Well, since you've got secant and tangent and cosecant, you'd end up having to convert something to like cotangent or something, because so you could use those exactly like what Aiden was saying, and you could use that to get there. It would just be harder.
Can we do
10, you said?
10?
Sure. Aiden, you're looking confused today. How you doing? Did you eat breakfast?
Yeah, I had breakfast. I'm just like, I feel like we're not using the identities.
Oh, we're about to. Just wait.
The first ones are always.
We're about to use the heck out of the identities. Once we take questions on this homework stuff, well, we still might have to use a little bit of identities on this questions. You said 10, so 10, we're supposed to, we have to find cotangent of theta and secant of theta. And we are given that tangent of theta is -5. And no, I'm reading the wrong problem. Did I get anything right? Cotangent and secant is right.
Yes, but then
The sine of theta is 1/3. Sine of theta is 1/3. And tangent's negative.
Can we use the sine squared plus cosine squared equal 1 to find cosine? And then convert it to secant?
Probably. That's not the direction I would start it.
So we have sine. Should we make a triangle on this one?
Yes, and we should put the triangle on something.
Oh yeah, because tan's supposed to be.
Yeah, because that'll tell us where we are and what the signs are and all that stuff. SIGNs are. Signs. Where's tangent negative? Where could it be?
On the top left of the
2.
bottom right.
Here and here. So it's either this guy or this one. I'll undot it in a second. We know sine is positive. So which one of those two is sine positive in?
Quadrant 2.
Quadrant 2. So we know that it's here. What is sine?
1/3.
Yes. What is it on the triangle?
Opposite over adjacent.
Hypotenuse.
Hypotenuse.
Hypotenuse, yeah.
What can we do now?
We can use marker. So for that line,
Pythagorean theorem.
Seems reasonable to me. 1 squared plus x squared equals 3 squared. 1 squared is 1. 3 squared is 9. We subtract 1. We get x squared equals negative. No, that would be broken. 8, which means x equals plus or minus the square root of 8 which equals plus or minus, go ahead and walk it all the way out, 4 times the square root of 2, right? Which means that it equals plus or minus 2 times the square root of 2, and we know because we used our other stuff that it's negative 2 times the square root of 2.
That's so much easier than like solving it all out.
How do we know it's negative?
Because we were told the tangent is negative,
Oh, yes.
and so we narrowed down to a quadrant. So the cotangent
It's just negative 2 square root 2.
and the secant is 3 over negative square root of 2 times square root of 2. And then you rationalize the denominator, and Bob's your uncle, you'd have, whatever I said the answer was, negative 3 times square root of 2 over 4. Which, unless I'm greatly mistaken, is how we solved these in class, but I could be remembering.
Well, the audio also cut out at the end, so I was kind
Oh, I forgot about that.
of
I'm sorry.
trying to parallelics.
That's, I forgot about that. Sorry. This makes sense though?
Yeah.
Pretty easy peasy.
Can we do one from 18 or 20?
Yeah. Which one?
Let's do. It's basically just opposites of each other.
That's true. Ish. So which one do you want to do? 18 it is then. Okay. Let's do 18. So 18 is if the cosine of x equals 0.61 times the sine of x minus pi over 2. So, what should we do?
Okay, well.
We should probably use a cofunction identity. What do y'all think?
Yeah.
So, which one? What are we using here?
Sine theta equals cosine times pi over 2 minus theta.
I think we should use the other way around, right? We're starting with sine with the phase shift. We turn it back into cosine, right?
Okay, so you start with the one that has the stuff attached.
Yeah.
On both.
Because we want it to be just the plain one, right? Because that's the one we have the value for. So, what are we actually using?
Cosine theta equals sine times pi over 2 minus theta.
Now what?
Can we plug stuff in?
No. It doesn't quite match yet, right? We can use x instead of theta. I mean, that's fine. That's irrelevant. But
We have to flip the signs and the
yeah, this is backwards.
parentheses.
So this is sine of negative x minus pi over 2. Right? Which one eats the negatives?
Cosine.
Cosine. So this negative pops out to the front, right? answer is negative that one.
So, negative.
Mm-hmm. Let's do some.
Why did we pull the negative? Why did the negative on the second step come out?
We factored it out.
Oh, okay.
Mm-hmm.
And so why is it 0.61? I mean, negative 0.61? Yes.
Because the cosine, look, I'll walk it all the way out, yeah? No, I didn't walk it all the way out, but
Because we said it equal.
yeah.
So, okay.
So this equals 0.61. Divide both sides by negative 1.
Okay.
Bob's your uncle.
Oh, I don't know what that means.
I know what it means, I don't know why it means.
Okay.
I don't know why that is a. What are those? Those are not euphemisms. What is the name for those? Like
Sayings,
colloquial
idioms.
idioms. That's the word that we're looking for. Which is funny that it's evidence that by the time precalculus hits, my brain is broken because this morning I was using a lot of fun vocabulary. Speaking of, did anybody have to? Did I write it in? Actually, I don't know that I wrote it in y'all's class. Did I put an assignment on y'all's? I didn't, right?
I do not know. No.
Yeah, y'all the only one that didn't have to wonder what enumerated meant.
This just means that like it doesn't have a number?
No.
Okay. Well, then I give up.
Enumerated means to like list one by one. I told the other classes that we would do lesson in class and homework would be enumerated in class. And when I asked my first period class, how many of you had to look up what enumerated meant? Like 4 of them raised their hand. When I asked my second period class, they looked at me blank because they didn't read the whole thing. And it
I
seemed
don't check
very
my
typical.
Google Classroom in the morning.
Do what?
I don't check my Google Classroom in the morning.
Well, it would have been yesterday, is when I sent it out, but yeah. Okay, let's do some more fun stuff. Yeah, let's start with this guy.
Is this a part of last lesson?
This is the same lesson. We're gonna finish this lesson up. This is the part that's fun. Here we go. We're going to simplify. And I want to do that one, that way you have 2 things to look at. The secant of x minus the tangent of x times the sine of x. Now you remember all those identities that we were learning? Now we get to use them. This one's pretty easy.
When did you ever use any of this in your life?
Never.
So I have answered that question 2 or 3 times in this class, but I will answer it again. Are you ready? You won't. That's not the point of it. The point is to stretch a part of your brain. Actually, you might. Your engineer father might like squeeze you into like doing something. Who knows? He might like pinch and prod you into the field.
I'm trying.
And I'm sure he has. Okay. Now, what was I saying? I said we're going to use something, and then you said we're never going to use it, and you were right. So, what could we use to simplify this?
Hang on, what are we trying
We're trying to make it have less trig ratios.
So this is secant x minus tangent x. What is the sign doing?
Let's multiply.
Is it multiply?
Yeah, times tangent.
What?
Yeah, it's multiplied times tangent.
Okay, so can I put it in parentheses?
Yeah, if it helps you see things. So I told you a week ago, one of the first strategies you could use. We hadn't used it until today, but we're about to use the strategy that I told you. Does anybody remember what I said?
No.
No.
So we use the,
Turn it into sines and cosines. So let's start by turning everything into sines and cosines.
Turn the secant to cos.
Secant is just 1 over cosine,
Mm-hmm.
and then tangent is sine over cosine. And then sine is already sine.
Now what can we do?
There's something
What is
with
a fun problem? What is,
Okay, well, we have to do multiply first.
yeah, we do.
would anything cancel out?
Not yet.
And that's sine, do we have to multiply the sine times the cosine? So it's sine, and then just,
Sine times sine is sine squared.
oh. So, okay,
Mhm.
I got you. Is it gonna be,
What's the answer to this problem?
6?
6/8, right?
Yeah.
So this is.
So the answer to this problem is 1 minus the sine squared x over the cosine of x.
Okay, I wasn't sure if we're having to actually try to take out one.
And then that's the answer?
No, you can get a lot simpler even.
Hmm.
So there should be one chunk of identities that is screaming in your head right now. Now it probably isn't yet because this is the first one of these that we've done, and so we're not really exercising in that space yet. But there is a group of identities that has something on the board.
Pythagorean is the square.
Yeah, that's what I'm talking about. When you see a square trig function, you're probably going to use Pythagorean identities somewhere. Which Pythagorean identity would be applicable in this situation?
Sine squared theta plus cosine squared theta equals 1.
Sine squared plus cosine squared equals 1. We don't quite have one of this exactly yet. Could we manipulate this to make it look like something that's there?
Yes.
Yeah. How?
Well, we can't really. Can we add the 1? We don't have an equal sign.
If we subtract, can we subtract 1 over 1?
oh, did you multiply?
I subtracted sine squared from both sides over here.
Oh, okay.
Cosine squared equals 1 minus sine squared. That matches. That does.
Cosine isn't squared on the when we have that.
Oh yeah, but this matches.
Oh, okay.
Now what can we do?
1 second.
Why is the top one square?
Because 1 minus sine squared equals cosine squared.
Oh, you substitute.
I used an identity.
Okay.
Same way that we use identity to magic this into this and this into this. Now there's one more thing we can do.
Wait, I missed a step. Have to get to whatever's on the bottom.
This is just the
I'm still over there.
where?
Oh.
Here?
Yes,
I just subtracted sine squared from both sides. So now I've got cosine squared theta minus here equals 1 minus sine squared theta, right?
yeah.
1 minus sine squared theta is what we have on the top, and that, because of the identity, equals cosine squared theta, so I substituted cosine squared theta for this, because it's equal.
Okay.
And now that I think everybody's on the same page, what's the one more thing we can do?
Wait, where are we?
You
Right here.
can get
You
rid
can
of the
divide it by
cosine.
itself.
Yeah.
So it's just cosine x.
So you can't tell me that's not a little bit fun. Turn that ugliness into this. That's kind of fun. You can't tell me that's not a little bit fun. Let's do another one.
Wait, that's what I was writing.
Oh yeah, this one's exciting.
Which one?
We're gonna do guided practice 5. On 315. Oh yeah. This one uses all kinds of fun things. Supposed to simplify. Sine squared x. Oh, I said we're doing guided practice. That's fine. We'll do this one instead. Sine squared x times cosine x minus sine times pi over 2 minus x. We're supposed to simplify it. So, what could we do?
We can use one of the identities, or the Pythagorean theorem.
Sorry, I was confused for a second. Yeah, maybe the Pythagorean identity.
Or use the co-function. Yeah.
Yeah, let's use the co-function identity first. Clean up that ugliness.
So it would be
How do we get there? Is the question that I came up with.
you can move the negative sign pi over 2 minus x over to the other side, so now it's a positive.
There's no equals.
Are you gonna use the sine equals or the cosine equals?
Well, look at the co-function identities. You have sine of pi over 2 minus x on one side of one of the co-function identities, right?
Mm-hmm.
Yeah, what does that equal?
Cosine, cosine.
So what can we do with it?
Just turn that into cosine.
True. That's all we're doing on these problems, these simplification problems, is we're substituting one side of an identity for the other side of an identity until it gets as simple as it can get. All right? Now what can we do?
Sine squared cosine x, we have to multiply stuff from the left together first.
You're talking about the sine squared and cosine. Well, yeah, we can't do anything with it really. It's just there, right? There is something we can do on this that might help us. We got a sine squared, so we might end up having using Pythagorean identity, but there's something we can do to simplify it before we even go there. You could go ahead and turn this into 1 minus cosine. Now, you could do that right now. But there's something else we could do that's gonna make it a little simpler. If we look at these two terms, do they have anything in common?
Cosine.
Cosine. So what can we do with the cosine?
Okay, cancel.
Not cancel, but factor it,
Ooh.
right? So cosine of x times the sine squared x minus 1.
And so the negative cosine becomes a minus 1 because you factor it out.
Yes.
What did you say?
The negative cosine becomes a negative 1.
Yes, because that's just like we're doing like a regular polynomial. If you factor out an x, then the x turns into a 1.
Okay.
Same thing.
Okay.
It's just a big old fat ugly variable. So, what group of identities are we probably looking at? Pythagorean, right? Sine squared plus cosine squared equals 1, right? So if we solve that for cosine squared, it ends up being cosine squared equals 1 minus sine squared, right? We kind of already saw that. That doesn't quite match though. So could we force it to match somehow?
Add sign to both sides.
No, that'll put it back to being just cosine plus sine.
Factor out a negative.
We could factor out a negative here. Or what, but we can't just do that, right? We can't just, what?
Where did that come from?
From sine squared, we just did this. Right? And then subtract sine squared from both sides, from the identity.
Yeah.
You can futz with the identities because they've got equals, right? So you can use a little bit of simple algebra to move them around. So can we make this side with this equation into that?
Unless you divide the entire chunk by -1.
Or multiply either one, yeah. That will totally work because it's an equation, right? So we can do it on both sides. So negative cosine squared theta equals, if we want to rewrite it in that order, because of commutative property, it's totally fine. The sine squared would turn positive, and the 1 would turn negative, and now it matches. So now what can we put in parentheses over there?
Negative cosine.
Negative cosine squared. So we end up with cosine x times negative cosine squared x. What's one more thing we can do to clean it up?
Will it end up,
What the cosine?
well, we could factor out.
What is x times x squared?
X cubed.
X cubed. So this would be negative cosine cubed x. The book says this or this, which is stupid. This is clearly the better answer, like unquestionably than this one. So I don't know what they're thinking. All right, let's do another one. Y'all having fun yet?
I woke up this morning, so now.
Oh my gosh. Life is good.
I was in a good, like a burrito, and I did not want to get up.
You were cozy. It was less about the waking up and more about the getting up. I follow that. I guess that makes sense. All right. Aiden, you having fun yet? I'm having fun. It's great. It's good stuff.
Did it equal after those so long?
I don't want to. You can't make me. Sine, cosine over. Actually, let's not do that one. Let's actually do one of the GPs this time. Let's do the uglier one. Cosecant x. Speaking of uglier one, it's time for this to go over there. Oh. I like this new teaching thing. It's like a chair. Cosecant x over 1 plus secant x. Plus cosecant x. Oh, is it 1 minus, I bet? Yeah. 1 minus secant x. Now we're supposed to simplify. What do we do?
Turn cosecants into 1 over sine, and we turn secants into 1 over cosine.
So we could do, and that's not necessarily that is not necessarily a bad path to go ahead and turn it into sines and cosines. I think what we should And it wouldn't be many more steps, but we'd end up with some compound fractions sooner. And we will have to deal with compound fractions, but I think let's try it a different way. Because we're gonna have to do this step anyway. May as well do it now. So, we got two fractions that are added. We need to add them together.
Go cross multiply.
No, this is not a proportion.
Get the bottom 16.
Oh yeah, so butterfly method type, yeah, all yes. We're not gonna cross multiply, but we are gonna get a common denominator. Yes?
I thought of something, but I realized it was wrong.
Okay. At least you're thinking. Okay, so the common denominator would be 1 plus the secant of x times 1 minus the secant of x. And to make sure we are tracking, if I was doing 2/3 plus
Is this like
5/8,
It's like when we do the brackets.
I would multiply this one times 3/3. Yes, it is like that. And this one times 8/8, right? And that's exactly what we're doing here. The denominator just to be the denominators multiplied together. So this one times that one, yeah? And this one's going to be cosecant times that. Which we can go, no. That's always a tap dance a little bit in pre-cal. What intermediate steps do I skip and which ones do I not? Sometimes I pick right and we're all falling great. Sometimes I pick wrong and you're like, wait, what happened? But usually, I have students that care enough to actually be like, wait, what happened?
So
Now what?
they're added because you just multiplied.
They're added because of this.
Well, yeah, but
Because that's like this one, like when you finish this out, the bottoms will be multiplied, and then this would be this one plus that one on the top.
so
Yeah.
with the bottom, you just wrote it out once instead of splitting it and writing out twice. Because like you could have wrote the bottom twice for 2 fractions.
No, we're trying to get it as one fraction. Like this one, like we did it, it would be a 16 plus 15 over whatever that is, 24, right? And then you'd add those together.
But you could do 16 over 24 plus 15 over 24.
No,
With
that would
the
be
same
it.
thing.
Yes. But then you would have to actually do it, you would do this.
Yeah, but it is basically that.
Yes.
It's still the two
Yes,
fractions.
it is. Yeah.
So we
Well, it's one fraction. Now what we do?
expand out the bottom. Multiply.
Yeah.
That's what's
Distribute. What's cosecant times 1? Cosecant.
Why do you have cosecants on the bottom?
I don't.
Oh, you're doing the top, okay. I did them in 2 steps.
I did something wrong. Oh yeah, this one should be plus. Yeah.
You can-
This time I did skip an intermediate step, kind of. I did it on purpose this time because I want you to be able to see something. The denominator is going to end up being 1 minus secant squared. So all I did was the first and the last. I didn't do the O and the I. Why not?
Because
Yeah, because these are conjugates, right? If you're multiplying conjugates, the O and the I are always going to cancel, right? So there's also some stuff that cancels on the top. This is not like something that always happens, but in this particular problem, this is going to go away. What's cosecant plus cosecant? Yeah, 2 cosecant. That's right. 2 cosecant of x over 1 minus the secant squared. X. Okay. Now what could we do?
how could we turn it to sine cosine?
We could, if it's easier. We don't have to. There is an identity that we have that has secant in it.
The odd even?
No, not the odd even one. It's squared. Where should you be looking?
Pythagorean, but there's tangent in there as well.
That's true, but it gets the addition out if we use it. So what does that identity say?
Tangent squared theta plus 1 equals secant theta. Secant squared theta.
So if we subtract 1, we end up with the tangent squared theta. We'll put the 1 in the front. So equals -1 plus the secant squared theta. Now we have the same sort of problem we had a minute ago, right? Or a few minutes ago. What is our problem and what do we do to fix it?
It doesn't match, and we have to take out everything.
Yeah. So that one is going to equal negative tangent squared theta. Right? So we can turn this. You don't have to, as you get to using these, you don't necessarily, and you can always if you want, it's fine. But it's fine if you don't write the manipulation of the identity thing. If you just be like, oh yeah, that's going to equal the negative one or whatever. You can write, but you don't have to. So this is going to equal 2 cosecant x over the tangent squared negative, thank you, tangent squared x. Okay? So we could probably circle here, or see if this gives instructions out or not. So it's arguable whether this is more simplified or whether this is more simplified. I like to, on tests and stuff, write whether you're supposed to write your answer as everything in the numerator or not. But if it didn't tell you that, it just said simplify, if you circled either one of these answers, it would be fine. If it didn't say. If it did say write your answer only as in the numerator, then it would be this one. Yeah?
And that one's a thing because of those like quadrant.
Yep. That's right.
Why is it caught instead of negative tan squared?
Oh,
Oh, squared.
does that make sense now?
Because cot's negative.
Yeah, it's cotangent, but yes. We don't have cots. No naps in math class. That wasn't even like a joke, but it was great timing. Okay, so uno más in this lesson. The instructions are a little bit different, which is a little scary, but not that scary. We want to rewrite 4 over the secant of x plus the tangent of x as an expression expression that does not involve a fraction. I was trying to decide whether I thought this one should be done like, no, it's in the tangent's gonna break it. Yes, you probably wondered, like they do the example in the book. There's often on a lot of these problems, especially when we get to the next lesson, there's a lot of times like a half a dozen different ways or more to solve these problems. So, what could we do?
You can't multiply both sides because there's not both sides.
No, but we could multiply the numerator and the denominator by, excuse me, by the same thing,
Yeah.
which is what we're going to do. We're going to multiply it by the conjugate. How does that sound?
So multiply it by negative secant x minus tangent of x.
It only flips the middle sign. Again, there's potentially other ways. I was trying to decide in my head a little bit whether converting to sines and cosines would make this easier. But I don't know that it actually does. You could certainly try it that way. This, I would argue, that multiplying something by a conjugate is a strategy to keep in your back pocket, because sometimes that helps. It cancels stuff. It also, as is the case here, it also squares stuff sometimes. And when you square stuff, Pythagorean identities, which have ones in them. So that could be helpful, right? So numerator's easy money. Yeah, just four goes in there. We don't care about the numerator very much. So all we're really trying to do is make the denominator disappear, essentially, right? That's kind of our goal. So numerator, we've got 4 times the secant of x minus 4 times the tangent of x over secant squared x minus tangent squared x. So what is the useful identity for us?
That means secant squared plus what is something wrong with that? Tangent squared plus 1 is secant squared.
Okay. So, using this once would be useful, right? Because then we could get the denominator in all the same trig function. So which direction do you want to use it in?
Turn. Get rid of the secant.
Get rid of the secant. So if you get rid of the secant, you'd have to subtract 1 from both sides. And end up with, because you have to have a tangent, which would be fine. You can do it either way. Either one's work. Like literally is 6 and 1/2 dozen the other. So
I did not care.
just go. I hate this so much. I want to be a burrito again. I'm gonna leave it the way it is, and put the tangent plus 1 here.
Oh, okay.
'Cause why reinvent the wheel when you don't have to? Because look what happened.
Oh, we just get a little.
Looky. You could, and either one, like either this or the 4 factored out version, either one of those would be fine. Either one of those answers would arguably be just fine. All right, your homework for this lesson. I think you're gonna have a short assignment on the next lesson too, but we'll see. Yeah, you will. Well, we'll see. Especially since the next lesson is kind of more of the same, but slightly different because equals. I think, if it's what I'm thinking it is. Let's do same page, 317. Let's just do, oh no, that's even better. Let's do, I don't like that, but that's fine. 22 through 46 evens. Great. And then let's get started on lesson 5. Verify trig identities. You're out of paper. You've been out of paper. You can get some more paper. Yeah, verify. So this is more of the same, but with a little bit of a difference. These,
They always say that in math.
well, maybe. We're going to jump in straight with an example. We're going to verify that the secant squared theta times the cotangent squared theta minus 1 equals the cotangent squared theta. So it's the same thing. We're using identities to manipulate this and stuff, but we have a specific end goal. And so there's different ways. So I allow you to manipulate both sides. There are some teachers and some professors who, on these problems, only let you change one side or the other side. But that's not what I do. It's not what a professor I know at South Plains does either. You can manipulate both sides. Either side. And sometimes it's easier to start with one side or the other side. But we're trying to turn one thing into the other thing. So, what should we do?
We divide both sides by cotangent squared theta.
You could, but what is that going to break? Because we have to divide everything by cotangent squared theta.
No negative one.
Yeah, so we're going to end up with a fraction here.
What are we trying to solve for?
We're trying to make both sides look the same.
Oh,
Can you get rid of the secant somehow?
Yeah.
I'm multiplying it times its, whatchamacallit.
That's how you would get rid of the secant squared theta, if you wanted to. It's not necessarily a top. I don't know. Now, that's another thing. I alluded to this the other day. On these problems, there will be times when you go down a path and it keeps getting uglier and uglier, and you're like, I give up. I have to go back up here and try again. What if we start instead with strategy number 1?
Switch things.
Turns into sines and cosines. Let's start with that. Because something may disappear over here. Something may happen. Let's take a look.
1 cosine theta times
Oh,
They cancel out, 'cause,
I cancel out.
we have a thing for that. We have a.
We do.
thing for that. Oh, yeah, it's already raised 1.
What is the Pythagorean identity that goes with these?
the
Pythagorean identity. What does it say?
cosine squared plus sine squared.
Not that one. we need cotangent.
Cotangent squared theta plus 1 equals cosecant theta.
Tangent squared theta plus 1 equals cosecant squared theta.
So you just add the.
So we subtract 1 from both sides and then it matches and it's cotangent. And so this turns into cotangent squared theta. And we verified. Done. Yay! Got time to quit? And I think you don't have quite enough tools in your tool belt to give you any more, so we just got through 1. So we'll leave, and I gave you more homework on the other one that I really wanted to anyway for a Thursday due date. So that's the last of the homework.